Hi, today we're looking at this slightly retro book on Algebra 1 and Algebra 2 from the 90s. It's called The Algebra Tutor, Algebra 1 and Algebra 2, Volume 1 by Willie L. Thomas. Now, I'm not actually totally sure what's the title here and what's the subtitle. Like, is the book just called The Algebra Tutor? I don't know. It turns out it took me some difficulty to find the second volume of this book, which I was also slightly confused about, because does this book cover Algebra 1 and Algebra 2? That's what Volume 1 has? Or maybe Volume 1 only covers Algebra 1, and Volume 2 will cover Algebra 2. I don't know. It's quite difficult to say unless you do the research. I've done the research. I can tell you, Volume 2 covers trigonometry and college algebra. It says something like that. But so this is Algebra 1 and Algebra 2, supposedly, all in this manual under the so-called Algebra Tutor series. My brother said that this looked something like Soviet propaganda, the cover, which I suppose it kind of does. It's kind of a funny cover. You got the kids here that are like, I don't know, why are they pointing? Like it looks like they're all facing backwards and pointing, which is strange because why would the lecturer in a classroom be way in the back? And he's also like disembodied and floating way above the kids. I don't know. It's kind of a funny, strange cover design. I guess based on the arrangement of a classroom, some of the kids might be facing the wrong way. I don't know. Seems like a strange arrangement. Looks like that fella's got a tie there. They're dressed very well. Back of the book, pretty minimalist design on the back, created to challenge every child's ability. A nice mission, and it says first edition. This is the first edition of the book from 1998. I do not know if there's a second edition of this book, but this is the first one. I guess the MSRP would have been $26.50. I got this book for probably something like a nickel. I actually got it as part of a deal at a library in a town near where I used to live. This local library every year would have the most incredible deal you could imagine. What the deal was $1 a bag. You go into the library, go downstairs, you can fill up a bag with books, and you pay $1 for each bag of books. You could buy as many as you want. And I found this book there, and that's where I got it. So I probably paid $1 for this and like 20 other books that were in my bag. Open it up. It is by the P.J. Thomas Book Company, an independent publisher from Jackson, Mississippi. Never heard of them. I don't know when this book was released. It said first edition 1998, but then this copyright says 1990. So I'm not sure how all of these dates line up. Let's take a look at the preface of the book. I always enjoy the prefaces in math books to really get an idea of what the intention was behind the book. And this one is no different. Pretty interesting preface. Says that this is for average and below average students. So this book is not targeted to the high performing student. It is targeted to challenge students who are average or below average with mathematics. And it's interesting to me. We'll take a close look at the contents, but the fact that it's covering, it says Algebra 1 and Algebra 2 in such a thin book. If you're familiar with the popular Algebra 1 and Algebra 2 textbooks that are used currently in high schools, they are gargantuan. They are bigger than like an advanced placement calculus textbook. So pretty interesting. The motivation to write this book came from talking and interacting with students in my various summer school classes. I guess the author was often told that if he had been their teacher, they would not have failed their algebra courses, and so he decided he would write this book to share his ideas and techniques. And so this probably helped a lot of people back when it was released. I'm guessing it didn't take off. I've never heard of this book outside of seeing it on my own bookshelf. I'd like to thank my wife for allowing me to use her dining room table and chairs for so many months, and my children for keeping me supplied with sharpened pencils and blank paper neatly stacked, and my daughter for her fantastic artwork used on the cover. Oh, that's cool. So Willie L. Thomas's daughter did the cover. Cool. It says that the author, here in the About the Author section, which interestingly comes at the start of the book, his teaching experience ranges from second grade to freshman in college. That is quite a wide range of experience indeed. 21 years of teaching experience. So I imagine after teaching for 21 years, you really see A lot of different struggles with the various concepts covered in Algebra 1 and Algebra 2. And these are critical skills covered in these courses in high school. If you're going to move on to calculus and more advanced mathematics, the things covered in these courses need to be really trivial as far as their difficulty goes. The table of contents here is kind of interesting because at a glance it's very repetitive. It just says, let's practice, let's practice, let's practice, let's practice. But here and there you can see that we're switching to a new subject. Definitions and examples of essential terms. Okay, so I guess we're starting off with like a lot of vocabulary. Then you move on to the multiplication of binomials and trinomials. Then you get on to long division of polynomials, which I think would typically be covered in Algebra 2, which is interesting that that's already on an Algebra 2 topic. And you can see the answers are here as well, right? You've got the let's practice number 4, for example, on page 11, answers on page 143. So this probably has all the answers to the questions, I think is the goal of this book, which has the feeling kind of like a workbook, something you might work through during the summer, say, to help prepare for like an honors algebra course. Or I guess given the target audience, you would use it to prepare for a standard Algebra 1 or Algebra 2 course. Transforming equations involving division. I'm not positive what they mean by that. Do they just mean like what you would do in say, an elimination type problem? Transforming equations involving multiplication? Have to see. I'm not sure. It goes on, solving equations using several transformations. So I think they're talking about like elimination there. And then solve equations with similar terms, monomial factors, difference of squares, factoring trinomials, all very important. Special cases of factoring, so maybe they'd cover difference of squares and cubes, that sort of thing. Factoring by grouping, more than one method of factoring, solving equations of factored form. Looks like a little typo there. There's a space between the N and the S. That's kind of funny. Simplifying algebraic fractions, multiplying algebraic fractions. It's kind of interesting to me that they cover so much stuff before digging into fractions. I guess by algebraic fractions, they mean fractions with variables in them. That's probably what they mean. Then they get on to proportions, the addition or subtraction method. I don't know what a lot of this stuff is talking about, so it'll be interesting to see what they mean. Slope-intercept form. I tell you, the ordering of topics here is quite surprising to me. I mean, what is all of this other stuff if slope-intercept form comes after? Like, we're doing factoring, and I think we're solving equations, and then we're going to slope-intercept form? Interesting. Whole section on translating word phrases into mathematical expressions or equations. That is an important skill if you're going to try to solve word problems that I think can really go overlooked. If you have a lot of experience, it can be a surprise how difficult this type of task is for somebody to take words and translate it into mathematics. So I think it's great that they included a section on that. And then you get integer problems, coin problems, that's funny, manipulating formulas, and a glossary. All right, let's take a closer look at some of these topics. The very first page after the table of contents is on the order of operations, which is interesting. It's like a list of commandments you must follow for the rest of the book. Evaluate all powers. Oh yeah. Do all addition and subtraction from left to right. Very good. Then you get an introduction to the Algebra Tutor. So this is just talking about the language and like notation of the book, I believe. Dot means multiplication. When computed out, all of these have the value of 8, of course. In order to understand and do well in algebra, one should learn the language and be familiar with the basic terms, certainly. Have a section on grouping symbols. Interesting. I like that they have the fraction bar here as a grouping symbol, right? Because the stuff in the numerator is kind of its own thing that needs to be taken care of first. And the fraction itself is its own term that you should at times think about in isolation. Students ask me sometimes, like, why are you using brackets rather than parentheses? What's the difference? And I tell them, well, there is no difference functionally. However, anytime I choose to use one over the other, I will have a reason. So like if you ask me why I'm using brackets in any particular instance, I will have a reason. It has to do with aesthetics to a degree. Personally, I often use brackets when I'm trying to emphasize that something is being substituted or plugged in. Other times, of course, brackets are useful just to avoid having so many parentheses when you're like evaluating integrals and stuff. That can be really helpful. And then it gives you a bunch of practice problems. And like we saw in the table of contents, there are answers to this at the end of the book. So some of the formatting here is a little gross. You've got like number 9 here, 12 times this fraction. It kind of grosses me out that the 12 is aligned with the numerator instead of being aligned with the fraction bar. But what are you going to do? Same thing with this division symbol. Looks a little gross, but oh well, the intention I think is pretty clear. Then we talk a little bit about sign rules. It is very important that one must learn his or her sign rules in order to function well in a course of algebra. Yeah, definitely. It is unbelievable how much people will make mistakes with positives and negatives. Can be, I think, very frustrating for both teacher and student. So it's definitely worth spending a lot of time on positives and negatives and how they interact. Let's see what they mean with solving equations with similar terms. That's on page 26. What is that all about? Solving equations with similar terms. Okay, yeah, so this is just about combining like terms and whatnot. Looks like it, I don't know if it uses the phrase distributive property in this book, but at least here they call it the distributive axiom, which is interesting. I haven't seen the distributive property referred to that way before. It also does this thing where it provides what it calls look-alike problems. Here, for example, it says if you had trouble with number 4, 5, 8, and or 12, here are some lookalikes. So if you look over here at problem 5, you see you're trying to solve an equation with a 0 on the left side. You know, some little quirk like that can really confuse people. Nothing special really is happening, but people can be a little scared by 0. And so they give you a similar exercise and help you work through it. Pretty cool. I really like, for the most part, the formatting of this book. It's very spacious. Like there's so much negative space on each page, which I think would help students not feel overwhelmed. There's a lot to be said about modern textbooks and all the different notes and pictures and stuff that they have, but I think sometimes they can feel a little bit cluttered. And a lot of these older books, this one's not even that old. I mean, I guess it's going on like maybe 20 to 30 years now, depending on when it was first published. It's just very plain, unobtrusive formatting. So I mean plain in like the best way. There's just lots of room here, and I think it can make your head feel less cluttered when you're reading through it. I like here the explanation too. We're talking about solving equations, having a variable on both sides, and it says, remember the standard form. Left side has variables, right side has constants. Something like this, which doesn't actually matter, right? It doesn't actually matter what side of an equation variables are on. Sometimes I think it can be helpful to just establish a standard like this, a standard form, and that kind of just narrows your goals, right? What am I trying to do? I'm trying to get the variables to the left. I don't have to make any difficult decision about that. I'm just moving the variables to the left. I like to emphasize the mathematics of it, that it doesn't actually matter, but sometimes too you have to focus on the practicality of how useful it might be to just maintain a standard form. Variables on the left, numbers on the right. I mean, aesthetically, this looks better. This is how we would like to read it. X equals 7. If you flip this, 7 equals X, I would still read it as X equals 7, even though the 7 is on the left. So this is the better way to write it, just aesthetically, in my opinion. I think Thomas does a pretty good job here of explaining factoring by grouping. Look for common factors, group together the ones or the terms that have common factors, and then we do this regrouping, take out what you can, and you might notice some common factors that you can pull out. And sometimes you might want to look at more than one way to group terms to make everything work. So pretty well done job here, I think. A lot of these explanations I feel like are very carefully done, which is appropriate given the target audience. You look at something like this here, where we are factoring, and it shows you 3 ways you could write this, right? The simplest one, once you factor out a -1 on the left side of this expression, is 2a times -1 times -3 plus y. Or you could pull that negative in front and not write the 1, just put the negative in front of the 2, and then you have this. But then you could also switch the order of the y and the -3 so that you have y minus 3. They're all the same, but it specifies the latter is more standard. This is the way that, someone who's pretty comfortable with their mathematics would probably write the expression. It mentions this index finger technique. I'm not sure what it means by that. I want to see if I can find what the heck the index finger technique is. Let's check the glossary, because I know it said there's a glossary. The index finger technique is probably there. HIJK, HI, index finger technique. Inequality, I don't see it here. That's too bad. There's no index, I don't think, so bummer. But here's an interesting term, abscissa, the coordinate of the point on the horizontal axis where a vertical line from a given point meets the horizontal axis. I don't think I've ever seen that word before. Unfortunately, I was not able to find the index finger method wherever they introduced that, but I did find this cool picture of a calculator. I like that it has no plus or minus. It has the sign change key and equals and 0 through 9, but no plus or minus. That's kind of funny. I think this is an interesting thing here. They're talking about solving equations by factoring, and he remarks, if you cannot move the terms mentally, where we have x squared minus 9x equals 14, and we're trying to move 14 to the left side, if you can't move the terms mentally, here's the way to show your work. That's an interesting thing to say, right? If you can move the terms mentally, and you can do it correctly, then you're fine. And most teachers probably would not require you to show this work. It's quite straightforward. But if you can't move the terms mentally and you have to write it down, then you need to know you need to know some way to write it down properly, because if you write it down incorrectly, then you're probably going to get the wrong answer, right? What are we actually doing when we're moving a term? We are subtracting the 14 from both sides. It says bring in its opposite on both sides, and then you get your answer. So I think that's quite well done. So yeah, I think this is a pretty good book on learning or brushing up on Algebra 1 and Algebra 2. It's got a lot of commentary, a lot of explanations, a lot of examples. It's got full sections on fractions and all sorts of factoring. And it even has answers to all the practice exercises, right? It gives you tons of practice, and you can see all the answers here. We've got graphs, all sorts of good stuff. You can tell that this is a bit retro, right? I mean, these are like, I don't know, there's something charming about the scanned graph-looking images here. But even though it's an older book, the formatting, like I've said, I think is really nice. It would be a pleasant book to work through if you were trying to work through this book to learn algebra. It's not like beating you with just tons of information on every page. It's pretty clean. If you are looking for this type of workbook for Algebra 1 and Algebra 2, I'll leave a link in the description to buy this book on Amazon. I'm not sure how available it is now, but I think there's at least one copy available on Amazon. I'm sure it's out of print, right? So it's not the most available book in the world. Probably you'd be better served to get a more modern book for a couple of reasons. You could probably get one that has even more space in the book to like write your answers. A lot of this stuff, you have enough space to write your answers in the book, which just makes it easier to work with. But I think you could get some dedicated workbooks that really treat you to an enormous amount of space to work with. Chris McMullen, I think, might have some good Algebra 1 and 2 workbooks. But also, you could probably get some of these newer workbooks for less than this one. I think on Amazon, I saw this going for like $17, which is probably a little average as far as the price goes. You could probably get a modern one for around the same price, maybe even less. This also has some language, I think, that's not as common now, like the distributive axiom. I've never seen that before. Abscissa, I've never seen that used either. So some of the language might be a little outdated, but certainly, it's Algebra 1 and it's Algebra 2. You got your factoring, you got your fractions. Cool book, so maybe you want to pick it up. One more thing before we go, I'm just looking through the glossary. I do find some of these definitions a little lacking. Let's see, the definition of difference. For any two real numbers a and b, the difference a minus b is the number whose sum with b is a. I don't know if that's the best way that could be phrased. Integers, the numbers found on the number line, such as -2, -1, 0, 1, 2, etc. That seems very vague. The, all numbers are found on the number line, not just integers. What else do we have? Member of an inequality, the expressions joined by an inequality symbol. That's also weird because the term here is singular, member, but the explanation is plural, expressions. There's another one I didn't like. Real number, a number paired with a point on the number line, right? But didn't it just say that any number that's on the number line is an integer? So I don't know. That seems kind of weird also. Hypotenuse, the right side of a triangle opposite the what? What does that even mean? The right side of a triangle. Obviously, that's bad because the orientation of a triangle does not affect which side is the hypotenuse. But it says the right side of a triangle opposite the right triangle. Obviously, that's meant to say right angle. Okay, so I don't know about this glossary. Definitely the worst thing about the book I can see is this glossary. It does not seem super helpful. Numeral, a name for a number. Fair enough. This says, what is an open sentence in two variables? It says an equation of inequality which contains two variables. Isn't that an oxymoron? An equation of inequality? What the heck does that mean? I assume that's supposed to be or, right? An open sentence in two variables. It could be an equation or an inequality, which contains two variables. And it's an open sentence because it may or may not be true depending on the value of the variables. Here's another one, similar terms. Again, I feel like the definition here just contradicts the term. It says similar terms are terms that are exactly alike. What? What? Terms that are exactly alike. And then it goes on to elaborate, meaning the variable parts must be the same, but their numerical coefficients can be different. Okay, so it's terms that aren't exactly alike then. It's terms that are similar. Interesting. One more fun picture for the road here. I don't know if this was also done by Willie Thomas's daughter. I'm guessing so. I just noticed the hands. Like, I think that's supposed to be the teacher's hand on the back of the book. Looks kind of like an oven mitt, and it looks like he's pointing to like heart rate monitors on the blackboard here. Kind of a funny sketch. Anyways, that is the Algebra Tutor, Algebra 1 and Algebra 2, Volume 1 by Willie L. Thomas. This first volume does contain both Algebra 1 and Algebra 2 material. Volume 2 contains like more advanced algebra and trigonometry. And it seems like a pretty reasonable, solid book. Like I said, I have a lot of problems with the glossary. But besides that, cool little book.